Şeyin piyasaya dönerse bahanışlar kısmı başı şeyin ve kaydına şey o gırdaşınay. Gahajla elanlaşan. Sibi elanlaşan. Hello everybody, my name is Shane Piazza. I come from Gahajla, New Mexico, and I currently go to school at Sibi. I'm here presenting my project, Changes of Vegetation Growth over 20 years and mixed grass ecotones in the Sevilleta National Park. I am right now, my project is studying vegetation, and vegetation is very important to the grassland. Sorry. The grasslands are really important. They encourage biodiversity. They also help with wind erosion, especially here in New Mexico. Sometimes the wind can reach up to 40 miles per hour, and the grasslands help hold the soils down. But the thing about the grasslands, they're easily disturbed. And what I'm using to study vegetation is GIS, and a lot of people have a misconception about GIS, and they always ask me, how do I do it, how do you do this, or they're always confused or mystified by it. But the easy way I tell everybody is you get data into ArcMap or any kind of GIS application, and you manipulate it. And with those manipulations, you can make pretty maps, you can use it to showcase your data. And so just to give you guys like a quick GIT 101, here is a picture of deforestation in Bolivia, and that's using GIS applications to show the deforestation. And this picture, this is a fire map. It's also GIS is very well used in bioecology. You can see the burn scar right there on your left, my right. And here's another picture, another big thing that's going on right now in GIS is they're using GIS to see where they can get the most solar radiation to put out the most energy for solar panels. So the redder it gets, the more energy it puts out. And GIS is only limited by your imagination. That's the good thing about GIS. And one of the things that just recently came out in the Esri newsletter is they're using GIS to redirect the boating route so that they're not interrupting the feedings of where the whales are, and where the little red dots and yellow dots are where the whales are feeding, but the little pink lines are the boat's route, so they're using it to redirect them. So GIS is a very wonderful application if you get a chance to take a class, because it really helps you, gives you a way to showcase your data and make it easy for people to read. So with GIS, I've come here to Sevilleta, and Sevilleta has 5 biomes I just found out. I thought it was only 4, but one of the things I'm looking into is the grasslands. And the objective of my project is to model the speed at which the grasses expand and move over time. So I'm mostly looking at the black and blue grandma. As you can see, the black and blue are right there. But I have 6 plots, and they're 2 different locations. So this is the grazing plot. There's 2 on this side, and it's mostly blue grandma dominant. And there it is on the map, my big map making skills. And this is the Burnex side. This is the other side that I'm looking at. And then this plot I have 4 plots, and they're the control plots that were used for a previous study. This one is black grandma dominant. Another map of where it's located, and they're about 7 miles apart, just to give you an idea of where they are at on the right. So within these big 6 plots, I have 12 subplots, and they're about 3 by 4 meters long. And before they had taken the pictures like aerially right on top of it in the middle, and those were about 12 feet tall. But hopefully soon, they had first originally taken the pictures, because I'll be using pictures from 1992, and after the monsoon season, I'll be retaking the pictures. This is what the plant identification looked like. So in 1992, the people who had originally done the study, they went ahead and identified the plants, whereas I brought them back into GIS and I identified them using digitizing, and I'm just making little circles around it with a mouse. And I know I'm just, but it's actually a hard process. It takes me about an hour and a half to do just one photo, and I have 72. And each color represents a different type of species. And just to give you an idea of what things will look like, on one of my plots, I have pictures that were taken from 1991 to 1997. So I was just messing around one day and I was like, okay, I'm just going to overlay them together. And already you can see the difference in vegetation from 1991 to 1982, I'm sorry, to 1997. So 1997 is in the black and 1992 is in the pink. And just to get rid of the picture, you can see it better now. Because I haven't started taking my pictures because I have to wait for after the monsoon, I decided to make characterization maps. And that's just for me to help understand why, if the vegetation or the plants, individual plants have moved, why or what kind of stresses had made them or if they didn't. So I made climate data maps from PRISM. They're like temperature and precipitation, soil types, available water storage, soil adjusted vegetation maps, that's a SAVI, and the soil adjusted total vegetation index, that's a SAT. We had fun with those words recently. But I also did future predictions. So I picked the worst case scenario from INCAR. Here are mine. This is for temperature. This is from PRISM. So I download the data from PRISM and then I manipulate it myself. So I set the ranges of where it's at, and that's kind of how GIS works. And these are from 1992 to 2013. Those are only 2 periods of time. Usually you have to create an every year series. So I didn't have the time, so I just went ahead and got a graph. Made a graph to show that there is somewhat of a change, a decline. And I also did that for precipitation as well. And so the lighter blue it gets means the less water there is. And again, another graph to show a trend. And I wanted to see what kind of soil types there are on Sevilleta. And there's a lot, as you can see. So I just zoomed in of my 2 plots. So most of the plots have the turkey loam, which is that green leaf color. And I wanted to pick these 2 just so I could see how the grasses are being affected by the types of soil there are. And then I decided to correlate with the soil. I decided to do an available water storage. And this is just like how much water is available for the plants. And as you can see, in the areas that my plots are in, they get on the higher end of things. And to correlate with the water, you get the DEM. And DEMs are usually good to use for hydrology because then you can see where they move, which way the waters move, and the channels of them. And they're really pretty too. They're fun to play with whenever you make one. But this one I didn't make. I downloaded it from the set website. And then this is a SAVI. And SAVIs are really good to use because they were developed to correct for the influence of soil brightness when the vegetation is low. And we have a lot of bare ground, so that's why I decided to make a SAVI. And as you can see, the more green it gets, the more vegetation there is. And the more orange it gets, less vegetation there is. And my plots are doing pretty well. There's some green in them and there's some yellow. And then I decided to make a SAT-V. And a SAT-V is used to measure the senescence or the dead vegetation. Seeing as our grasses are most of the time yellow, that's the reason why I decided to make this map. And the more blue it gets means the more water it needs. And the more green it is, the more vegetation there is. And my plots need some water. I decided also to use remote sensing Landsat images, and these are reflectance. This map is made to indicate And this right here is what a vegetation map is. Usually made at a more greener places. You can see they're not as nice as the Savvy or the Savvy maps. And where the arrow is pointing at, over here, you can see where the farmlands are by the river. And then over here, you can also see the France sky from 2001. And that's one of the good things about GIS is required. And then here is my INCAR, my future predictions map. INCAR uses algorithms from the past to create predictions for the future, and worst case scenarios usually indicate like high population, high energy use, like going in the same direction that we've been going in already. So I made one for 2050, and the maximum is at 15 degrees Celsius, and the minimum is at 13 degrees Celsius. And then you can see the 2099 is a whole different color because the max is at 17 and the minimum is at 16. And then because those are only just two indications of two different times, I decided to do a graph again. Graphs are fun to make. And where the arrow is pointing at is where we're at now in time. And this is just showing, I got this also from INCAR, but just showing a 20-year mean for those years on the bottom. The temperature change. Work. I want to take the pictures for this year, for the 2014 year, digitize them, and then with that I want to quantify the change between the 2 years, 1992 and 2014. This is going to be ongoing, and I'll be coming back to retake those pictures, maybe in September or October. But I would like to thank everybody who helped me out. My mentors were Scott and Eric Wood. Amber, she was a big help with everything. And Stephanie, she was the one who digitized my photos for me. Or she brought them into the computer system. And Dottie, she was my driver. She's a wonderful driver. And all the other people that helped me, especially my family. I'm not a traditional student. I have a family, and I'm very lucky